Are we the only intelligent life in the entire universe? Or is the idea that we are alone actually one of the biggest myths ever told? Today, this myth-busting deep dive into one of humanity's most profound questions will challenge everything you think you know about our place in the cosmos, and the surprising truth about alien life might be stranger than any science fiction story ever written. For thousands of years, humans believed Earth was the center of everything. Then we learned we orbit the Sun. Then we discovered our Sun is just one star among billions in the Milky Way. Then we learned the Milky Way is just one galaxy among billions more. Every time we expanded our perspective, we felt smaller, less special, more alone. This is where it gets interesting. That feeling of loneliness shaped one of the most persistent myths in human culture, the myth that Earth is unique, that intelligent life is impossibly rare, that the universe is mostly empty and silent. People believe in this myth for emotional reasons as much as scientific ones. We want to feel significant. We want to believe that consciousness, intelligence, and civilization are precious anomalies. If Earth is special and alone, then human beings matter in a way that feels almost sacred. But the problem is that this myth is built on a misunderstanding of actual probability. Hidden history of detection failures, and urban legends about what scientists really think. For decades, the evidence people thought supported our loneliness was compelling on the surface. We had not heard any radio signals from alien civilizations, despite decades of listening. The famous Drake-Quasna formula, meant to estimate the number of intelligent civilizations in the galaxy, was often cited to suggest there might be only a handful in the entire Milky Way, if any at all. Movies and popular culture amplified this narrative. Space is dead, life is rare, and humans are alone in a vast, cold, meaningless void. This storyline became so powerful that it shaped how scientists framed their research, how science communicators explained the cosmos, and how ordinary people understood their own existence. The unexpected truth, however, is that we had it completely backwards. And debunking this myth requires understanding what real science actually tells us about probability, chemistry, and the nature of the universe itself. Here's the twist almost everyone gets wrong. The universe is not a sparse, empty place where Earth happened to get incredibly lucky. The exact opposite is true. The universe is aggressively, overwhelmingly fertile. Consider this. We now know there are more stars in the observable universe than there are grains of sand on every beach on Earth, combined. Not just more stars than sand grains. That number is around 10 to the 24th power. Now, NASA surveys have shown that most of those stars have planets orbiting them. Most, not some. Most. That means there are more planets in the universe than there are stars we can see in the night sky. Take a moment with that statistic. The number of worlds out there is so vast that our minds struggle to even hold the concept. But this is the part most people never hear. Even if the odds of life emerging on any single planet are incredibly small, say 1 in a billion, when you multiply 1 in a billion by a septillion, you do not get 0. You get a number so enormous that the existence of life becomes not a miracle, but an inevitability. Now, this is where researchers were stunned. We used to think life was fragile, dependent on Earth-like conditions that were nearly impossible to find. Then we started discovering extremophiles organisms on Earth that thrive in boiling hot springs, in frozen Antarctic ice, in acidic volcanic environments, and in complete darkness deep underground. These creatures showed us something crucial. Life does not need sunshine, liquid water at room temperature, or even air. Life is ruthlessly, relentlessly adaptive. And the more we explored extreme environments on our own planet, the more environments in space became potentially habitable. We found that there are likely more ocean worlds in our solar system alone than all the Earth-like planets with surface water we once imagined filling the galaxy. Europa, an icy moon of Jupiter, probably has more liquid water than all of Earth's oceans combined, hidden beneath its frozen crust. Enceladus, a moon of Saturn, shoots water geysers into space. These worlds are covered in ice, orbiting giant planets, far from any sun places we once thought were utterly dead, yet they may harbor life. Life, real science is teaching us, is not a delicate flower that blooms once in a cosmos. Life is more like a weed, ready to spread wherever conditions allow, adapting to almost anything. The real evidence, once you look at it carefully, points to a universe absolutely teeming with life. Consider the chemistry. The building blocks of life as we understand it: carbon, nitrogen, oxygen, hydrogen, phosphorus, sulfur are among the most abundant elements in the universe. We find them everywhere we look. We find complex organic molecules in interstellar space, in meteorites, in the clouds around newborn stars. The ingredients for life are not rare. They are common. We have found them on comets, on asteroids, on the surface of Mars. The universe is literally soaked with the chemistry of life. Yet for decades, this educational video topic was framed as a profound mystery. Why? Because we kept searching for signals from alien civilizations, and we kept hearing only silence. This led to a concept called the Fermi paradox. If life is common and intelligent civilizations are probable, where is everybody? Why have not we heard from them? This question became so famous, so culturally resonant, that it overshadowed a simpler, more obvious explanation. We have barely been listening. We do not know what we are listening for, and the universe is almost incomprehensibly large and old, and walls that make communication almost impossible by accident. But here's where it gets interesting again. In the last decade, everything has shifted. We have discovered thousands of exoplanets, and we have found that Earth-like worlds orbiting in habitable zones regions, where liquid water might exist, are not rare at all. Some estimates suggest there could be tens of billions of potentially habitable planets in our galaxy alone. Billions, not hundreds. Billions. We have also detected exotic signals and anomalies in space that we cannot immediately explain. We have found evidence that the universe is far stranger than we once imagined, with dimensions we cannot see, physics that defies easy categorization, and phenomena that suggest reality is far more complex than our current models allow. And here, as the twist, the very silence we once saw as evidence of our loneliness might actually be evidence of something else entirely. It might be evidence that intelligent life takes many forms, evolves at different times, uses communication methods we have not discovered yet, or chooses not to broadcast its existence across the cosmos. Now, this is where researchers were stunned once more. When scientists finally began to seriously examine the probability using modern mathematics and updated data, they realized something shocking. Even if we use conservative estimates, say, intelligent life arises once per galaxy. On average, that would still mean there are billions of intelligent civilizations scattered across the observable universe. Billions. Some estimates from astrobiologists suggest that intelligent life might be far more common than that. Some scientists propose that consciousness and intelligence might actually be inevitable outcomes of evolution given enough time and complex chemistry. The universe has been around for 13.8 billion years. Evolutionary processes have had vast stretches of time to experiment, to innovate, to produce complexity. The misunderstood science here is the assumption that intelligence is fragile or unlikely. In reality, intelligence might be one of the most robust outcomes of biology when given the right conditions and enough time. Let's talk about what the myth has cost us in terms of hidden history and cultural impact. For generations, the narrative of cosmic loneliness shaped how we saw ourselves, how we invested in space exploration, how we prioritized the search for extraterrestrial intelligence. If we were alone, what was the point? This myth became a kind of existential weight, sometimes leading to despair, sometimes to a fierce protectiveness over our home planet. Yet all along, the evidence was pointing elsewhere. The myth was not based on bad science. It was based on impatience, unlimited data, on the human tendency to project our emotional needs onto the cosmos. We wanted to be special and alone, so we built narratives that fit that desire, even as the actual probabilities suggested something radically different. Debunking this myth means letting go of a story that feels true but is not. The unexpected truth about alien life is this: we are almost certainly not alone. The probability, given what we now know about the size of the universe, the abundance of the right chemistry, the adaptability of life, and the vast stretches of time available, strongly suggests that life has emerged countless times in countless places. Some of it is probably microbial, simple, invisible. But given the same billions of years that gave rise to humans, many of those worlds probably host intelligent beings. Some might be aware we exist. Some might have technology so advanced it seems like magic. Some might be dead civilizations, ruins of species that rose and fell before Earth had oceans. Some might be communication networks spanning star systems. Some might be so strange, so alien in their nature and cognition, that we would not recognize them as alive even if we encountered them. The surprising truth is not that we are alone. The surprising truth is that we might be alone only because intelligent life rarely survives long enough to truly connect, or because the distances involved make chance encounters almost impossible despite the abundance of life. What myth should I break down next?